Hello. Hello, hi. I'm heewook who want to be an Intel certified instructor. Today is April 19th, 2021. Please understand if the pronunciation and context are weird, because I can't speak English. To introduce myself, I am a full-time instructor and I belong to Hancom Academy, an affiliate of Hancom Group in Korea, and the name of the previous company was Hancom MDS. I have been teaching USB, file system, embedded C language for more than 10 years ago. And I'm an Intel PSG training partner who has been teaching Intel FPGA for 6 years. I have been teaching Python, deep learning, and big data as a certified instructor since 4 years ago. In this video, I'm going to tell you why I think we should use DPC++ and what are the benefits of it. Then we will announce in more detail the core content of DPC++, which is code reused across the architecture wide. First of all, the DPC++ name description is short for Data Parallel C++. To explain one by one, the current situation for high-speed computing developers is that they buy multiple expensive GPU servers or use heterogeneous computers. Heterogeneous computers that replace past supercomputers include hundreds of GPU core and several FPGA in addition to the CPU that acts as a computer owner such as regular PC. Here, CPU is called host and FPGA and GPU accelerator that speed up computation. As you may know, FPGA is primarily used for prototype development and validation in the early stage of non-memory semiconductor development, and GPU is a graphic processing unit. Naturally, they both process data very quickly. In more detail, DPC++, the core language of the Intel oneAPI platform, a data parallel C++ language that can operate the oneAPI platform, a data parallel C++ language that can operate the same code on the FPGA and GPU as well as on the CPU. The reason for using same code on the FPGA and GPU as well as on the CPU. The reason for using DPC++ is that when you create a single integrated DPC++ code, you can create a code that can effectively operate multiple accelerators in parallel. In addition, considering the efficiency of the code and optimizing the performance, allowing the code to operate on each accelerator and host CPU is a key reason to use DPC++. It's often said that learning a new language is a low cost effectiveness because there are many obstacles such as setting up a development environment, learning grammar one by one, and solving errors. However, DPC++ requires only one API to be installed, and the basic C++ language makes it easy to read. And the related tools are in fancy GUI, so most of them can be solved with a click, which is high cost effective. If there is no development environment on the computer, install the Visual Studio Community version. Non-profit institution researchers, students, or individuals use it for free. The oneAPI installer automatically recognizes compilers such as Visual Studio 2017 or Visual Studio 2019 that were installed before oneAPI installation. At the end of the oneAPI installation, when you start the Visual Studio and select the type DPC++ console application for the new project, the default code is also automatically generated. Provide excellent user development experience from first-time installation throughout debugging and performance optimization. This is the benefit of using DPC++, which can be improved by developing and analyzing code that is extremely easy to maximize performance. For high-performance calculations, such as artificial intelligence, every code you use must contain many code that asynchronous parallel control not only CPUs but accelerators such as FPGA and GPU. If you try to operate at parallel speed, you will encounter many problems. And for troubleshooting or performance optimization for DPC++, great GUI tools such as Advisor, Between Profiler, Inspector Debugger, etc. are installed together to install oneAPI. More detailed information about code reuse across the architecture is how code can be reused for everything from initial development to error resolution, bottleneck resolution, and performance optimization for both CPU and GPU and FPGA. Let's think about the method we used before Intel oneAPI came out in the past. In the past, we have developed applications that want to create code for CPU, code for GPU, FPGA code, operate each separately, and operate accurately without errors, as well as maximize performance, which is very difficult, because in the past, code written in most computing languages only worked on CPUs, using FPGA, using Verilog HDL, using NVIDIA GPU, using CUDA, and OpenCL to use AMD GPU. It is difficult to study programming models that can understand the different architecture of mechanical language and register configurations. They also operate a variety of library code to improve performance, but they were not able to connect or version compatible. So it was too difficult to were not able to get the right version of the library or fix the error. With DPC++, all of these problems are solved by one code that works flexibly across the architecture. Code reuse across a variety of processor and accelerator and architecture allows data parallel C++ from Intel oneAPI to facilitate heterogeneous connectivity. The device you want to use can be selected from the device selector, queue it very easily, and then use the code you submit to the queue to act on the device you want. It is difficult to trace code that runs asynchronous parallel simultaneously across multiple devices to the execution point of view. It's actually harder to optimize performance for a cluster that connects supercomputer or multiple computers, because sometimes it works well in one accelerator brain, but it works slowly in another processor. Among the various analytical tools that can help ensure code reuse across the architecture are tracing analysts and collectors at runtime, allowing you to trace multiple program-driven process at the same time. This will show you how to improve performance further. Of course, Intel oneAPI doesn't do everything for you, but it's very helpful to write reusable code across multiple architecture. You might be wondering this after watching this video. I don't need to move fast. We don't have that kind of supercomputer. However, blockchain and artificial intelligence became essential during the fourth industrial revolution, and artificial intelligence has recently used a lot of deep learning, and deep learning still requires a lot of resources. This future situation does not have a precondition for the first question. I'm only going to slow down. Intel has also prepared the answer to the second question. We don't have a supercomputer. Subscribe to DevCloud for free and use a heterogeneous computer with 192 gigabytes of memory for 6 months via DevCloud for free. This will be discussed in the next video. If you want more information, you can find it on the Intel Software Partner site. Thank you very much for watching the video for a long time. I pray you have a very happy day.